security through obscurity has been proven to be a really bad idea. I mean, after all, who doesn't know about the key under the mat or that little magnetic thingy in the car wheel? Well, yeah, if you're counting on that kind of stuff for your electronic design, well, best of luck to you. To get real security, we need known, proven mechanisms. So, what about extending that idea to its logical conclusion? Yep, I'm talking open source. With FPGAs making a name for themselves as high-performance computing platforms, particularly taking advantage of languages like OpenCL, we have an opportunity to accelerate open-source security algorithms in a whole new way. Hi, I'm Amelia Dalton, host of Chalk Talk. Intrigued with this idea of accelerated open source security? Me too. Let's chat with Ryan Kenny of Altera to get the details on this evolving trend. Also, before we get started, remember to click that link. There you can check out a video about how Altera FPGAs can accelerate open source security using OpenCL. Welcome, Ryan. Thanks so much for joining me today.
Thank you, Amelia. Good to be here.
Okay, so we're going to be talking about open source security. Now, I thought that was an oxymoron. What's up with that, Ryan?
Well, most security solutions out there today are proprietary. We know that. But the only way to really make a solution work, to make it scalable, to go to entire enterprises, to go nationwide, to go across nation states, really is to do something where everyone knows what the elements are, what the threat descriptions are, etc. So we really need to move to open source to get to a scalable solution. That's really the issue. Sure,
that makes sense. So who's interested in this? Who's going to pay for it? It seems like a lot of people would be interested, but what are the players here?
So this problem really is larger than one company. So a lot of the funding has been sourced federally. A lot of it has been coming from the Department of Homeland Security, from various research arms of the government, from various military research organizations, etc.
Sure, that makes sense. So what's the progress for an open source standard? Who's driving this?
It's been driven by some funding from Homeland Security, as I mentioned already, but in order for it to catch on in industry, it has to come from an industry body. And there has been an industry body that's formed to address and to develop these open source standards. And they're developing these open source standards based on work that's already been done by Mitre Corporation and other elements of the government.
Okay.
So this open source foundation is called the Open Information Security Foundation, or OISF. Altera is a member. And there are a variety of other members that are listed on their website that you can see.
Cool.
So these are all players that are interested in developing it and can contribute to either the software or the hardware elements of an open source solution.
Okay, so Ryan, let's drill down and talk about some specifics here. Sure, open source is a great idea, but is this just a list of standards or is some actual work getting done?
Yeah, that's actually a common criticism. Mitre Corporation, for example, has been working on this for a long time, working on common sets of threat definitions.
Okay.
But they have been just paper studies for many, many years.
Yeah.
So it's not until recently, with the formation of OISF, that they've really focused on developing an open source product. So that open source product, and you can see this on their website, is called Suricata.
Okay.
Suricata is the first network security monitoring engine, or what's called in the industry IDS and IPS, intrusion detection and intrusion prevention.
Okay.
So the Suricata engine is multiple kernels that provide some of the same security capabilities of some very private or non-open source solutions that corporations pay for today.
Okay.
But again, all open source, and it's all in beta and available today on the Suricata website.
Okay, that's really cool from an industry point of view. But last time I looked, I was at Altera right now. And so what's Altera's role in all of this?
Well, that's a very good question. One of the problems with using an open source engine of some kind is that it's just not optimized for high speed or high data throughput.
Right.
It's optimized for malleability and the ability to accept changes as the threat definitions change. So in order to get this thing to run fast enough to be actually usable to a company or to a nation state like the United States, is to accelerate this open source engine, to accelerate the kernels themselves on hardware. So that's how we get to 100 gig pipes, 400 gig pipes, and to make this usable and acceptable as a solution for very high speed networks.
Sure, that makes sense. So I think I got the idea of why using an FPGA to accelerate Suricata would be a good idea, but what does that really look like? What's going on here?
So when we talk about accelerating the Suricata engine on FPGA, we are using our OpenCL programming flow. It takes C code, or OpenCL standard code. It divides that code into RTL objects and code objects, accelerates portions on the FPGA, and leaves some of the more malleable elements in software to run on, for example, the SoC product from Altera.
Sure.
So what we've done is we've looked at the various kernels that make up the Suricata IDS and IPS engine. We've divided it into phases of work. And what we've done today is we've demonstrated in phase 1 the first kernel of the Suricata engine, which is the IDS packet analysis, or intrusion detection element.
Okay.
So this is really the first generation of what you'd see as a standard firewall from a corporate product standpoint.
Okay.
We've implemented this completely on an FPGA, and we've demonstrated it on a partner card that uses the Stratix 5 FPGA.
So you've already demonstrated that ability, but what's next?
So after we optimize the IDS portion of the Suricata engine, we'll focus on the other kernels that make up that solution. This includes a deep packet analysis kernel that we show here as a phase 2 effort that will use extensive memory interfaces, which is another reason, by the way, you want to focus on an FPGA solution, is to get the high-speed interfaces necessary to do deep packet analysis or deep packet inspection.
Sure, okay.
So then you move to a phase 3, and these are the IPS manipulation kernels of the Suricata engine. IPS, again as a reminder, is intrusion prevention system. So this is where you'll actually take action when you see malicious packets.
Gotcha.
This is where you'll either modify them or route them differently so that they don't cause any damage to the network or obviously execute any other malicious code.
Right. So what's the outcome of all of this? Do you mind recapping your main points for me?
Yeah, the importance of this, we believe, is that a group within industry needs to come forward, needs to address the needs of an open source security solution.
Yeah.
So what we need to do is form a team of software developers, hardware providers that can provide a solution to open source security that has all of the benefits of open source, and that is the ability to react quickly when we recognize new threats, is to share the threat information and to update the engine automatically, just overnight. What we want to do is be able to take a 0-day threat and turn it into a 5-minute threat. We want to be able to react across a very large enterprise immediately. So what we need there is all the benefits of FPGA hardware acceleration. It's not enough to have a solution that can react quickly. You have to have a solution that can be accelerated enough to match the explosive growth in internet rates.
Yeah.
Especially if you want to be on company pipes as well as large aggregated traffic pipes on today's internet infrastructure. And most importantly, this has to be all commercial technology. If the government's going to invest in this, they cannot invest in a solution that turns over as quickly as solutions do in Silicon Valley.
Yeah.
So it has to be an open source standard that can be fully documented, can be picked up, can be updated, and can be sustained over a large number of years.
Excellent. Well, I'm excited to see the progress of this. Thank you so much for joining me today, Ryan. It was a pleasure speaking with you.
Yeah, thank you. I appreciate it.
And before we get started, remember to click that link. There you can check out a video that explains how Altera FPGAs can accelerate open source security using OpenCL. For Chalk Talks, I'm Amelia Dalton. For more Chalk Talks, check out the on-demand section of eejournal.com or EE Journal's YouTube channel.